Okay, let's get started. Are there any questions? Yeah.
Are we going to start on the assignments or just more of
So should you start the first assignment? Is the first assignment out? Yes. So what should you do? Start it. Should you wait until next Thursday to start your assignment? Should you wait until next Tuesday to start your assignment? I hope you don't. I advise you strongly to start today on the first programming assignment. Labs, do labs start next week? Yes. So should you go to your lab section next week? Yes. All right. Cool. Any other questions? Okay. So what did we talk about last time? We started to talk about the C++ language and tried to understand all of the things that I hand waved about how the C++ language actually works. We're going to try to dive a little bit deeper, starting with what we did last time, which was getting an overview of what the main parts of a C++ program are, what all these special characters mean, although we didn't go into too much detail on those. And then the last thing we saw was that C++ is case sensitive. So if you have a variable with a certain name, you have to use the exact same name if you want to use that variable in the right case sensitive part. All of the names do not have to be lowercase, but things like main and int and all of the things in C++ already are, so it's highly recommended that you stay lowercase as well. Okay, so let's get on to the next few things. So we saw this cout thing, which was, so what is cout responsible for? Outputting things, right. So it displays information. So these double less than symbols, all that means is that whatever comes after it, that's something that's going to be outputted to the screen. So if I wanted to print some text like this, I do cout with this weird less than operation with the thing that I want to actually output. But if I wanted to print multiple things, then as we saw last time, we can do this double less than thing multiple times. So if I wanted to print some text like hello, and then maybe a variable instead, then I need to have an additional double less than symbol. But and another way you can do it is do one entire cout statement with the first thing you want to output, then the next cout thing, and then just keep going from there. So we kind of already saw how to do this. But what you may want to do is, if you want to print two things on the screen, but you don't want them on the same line, you want one on the first line and then one on the second line. So why would you ever want to do that? Clarity. Well, what if you wanted to print like a series of options that the user can select? You can choose this option or this second option or this third option. Would that be nice for the user if all of them were on the same line? No, so it would be nice to have a new line. So there are two ways to do it, and it seems kind of silly that we have two different ways of doing it, but there actually is a difference between the two. So the way that a lot of people just use without thinking about what it actually does is this end-L thing. So if I did something like this, I would print cout hello there, and then this end-L corresponds to a new line. So if I did end-L, and then if I wanted to print something else after it, it'll appear on the next line. But the way that you should think about doing it instead is this \n thing, and because not only is that exactly what it means, a new line, because end-L does other things too. \n does a new line, but there are other commands / something else that we'll get to in a second called escape sequences. And so being able to use those is important. Yeah?
\n within H mark?
Yeah, you're correct, yeah. So if I did \n just outside of quotation marks, then that wouldn't make any sense because it's a piece of text. It's actually what is called a character. So we're printing a whole bunch of characters, the character H, E, L, and then all the way through, and then \n corresponds to a character. So we're technically printing a new line to the screen, even though it doesn't look like any piece of text to us. So yeah, so these are the two ways that you do it mainly. All right, so how would you actually do this? So if I wanted to print, so this is a little program we're going to work on a little bit today. So we have this little program that says that we're going to compute areas of circles. So it's not like the insanely great shapes on the first assignment, but so suppose that we wanted to print these 2 bits of text, and of course if I tried to do this just like this, it'll only print those 2 lines, but it didn't print it on a new line, right? So because I didn't have a new line character. So how can I fix this? Yeah, I can add the /n. Well, could I add it here? Would that work? Yeah, so that would be fine. And if I tried it, it'll print it on the new line. That's no issue. What if I left that \n there and I put a new line right there? What would happen? So it'll actually print an entire space in between because it's doing a \n at the end of the first one and then a \n at the beginning of the second one. Okay, good. So, and then if I did ndel right here, would it do the exact same thing? Well, what is one way that we can check that it does the same thing or different? Just run it. So let's see what happens. And it looks like it does the exact same thing. So, so ndel really does output a new line, but I'd caution you to use ndel everywhere because it does other things that are kind of advanced and we won't get to them toward the end of the semester anyway. So I would always recommend doing \n, but either one is okay for now. The only real difference you'll ever see is if you're printing a whole bunch of things and you wanted to have the printing be really, really fast, then \n is much faster than ndel because ndel does other stuff. But any questions on how to print a new line? Okay, yeah, that shouldn't be too hard to do. So we know how to do a new line. So I mentioned these things called escape sequences. So whatever happens whenever you have a / and some character, then what happens after there is something special. So \n corresponds to a new line, but here are other ones that you could also do. So \t is if you want to print a tab character, then you can do that. I can't just copy and paste a tab character into this string thing and then try to expect to output that because it might not be able to interpret what that tab character is. But if I do \t, it'll always do the right thing. These next 3 are just for your information. I've never used them, and you'll never use them unless you do a special project or something, but they're just here for your reference. But these 3 are actually pretty useful so to understand. So if I have another \, that means that I'm printing one \ character. If I did a single quote, that'll print the single quote character. And if I wanted to do a double quote character, I'll do \double quote. So what if I wanted to print something like, this program calculates the double quote area of the circle with a double quote on the beginning and the end of area. How would I do that? Yeah. We're at \quote. What if I just left it like this without the \ and I just did it like that? Well, it obviously complains. But if I tried to compile it, it'll actually complain to me because, so why do you think that there's an error here? Yeah. Right. So because that quote ended, the C++ thinks that the first part of the string is done and it's looking for an identifier called area, but I haven't defined it, so that's why it doesn't work. But here, if I do backslash on both sides, then that just interprets the quote there as you actually want to print that thing. So if I compiled it here, it'll actually do the right thing. And if I wanted to do a double quote on the beginning and a single on the end, then it's pretty obvious what I would do. So I would have a backslash double on the front and a backslash single on the end. And if I compile it, it'll do exactly what we expect. Any questions on how to print quote characters and new line? Oh, what if I wanted to put a tab between program and calculates? Backslash T, because that's the character. What if I did a backslash T space right there? Yeah, it would do a tab and a space. So by bunching these together, then I'm guaranteed that exactly a tab will be between program and calculates. So if I did that, then it prints a tab there. And in fact, if I try to select it, it will only have one character there. So we know it actually is a tab there. Any questions on escape sequences in general? Okay. So, yeah. Oh, I've never actually tried that. So let's let's see. I actually don't know what'll happen. Maybe it's something to do with the sound here. It may depend on the operating system too, depending on what sound libraries are on there. But some of these things are written in the old forgotten times of the 70s and 80s. So maybe it won't actually work. But the main ones you'll use are the first two and the last three. Well, namely the last two, but the last three as well. Other questions? Yeah.
What if you wanted to actually print \n?
Oh, good question. So if I wanted to actually literally print \n, what would I do? \\, so how far am I so far? I'm at the \. Do I need something for the n? No. So if I did that, and then let's just put a space for clarity, then it'll actually print that. What if I wanted to do 2 backslashes? 3 or how many? 4, yeah. Because 1 \/ corresponds to the directly next character, the subsequent character right after the first \. So those two you can think are grouped together. But if I wanted to do another one, I'd have to put 2 more \. So then I would have 2 \/ then n. Other questions? Okay, so that's escape sequences. So a / is different. So where did we see / before? Yeah, for comments, right. So / do not correspond to escape sequences. So they correspond to comments. Here's a question. What if I wanted to print 2 /? What if I just tried to do that here? I actually don't know what'll happen. Let's see. Oh, it actually does work. Okay. Well, that's not what I expected. Well, what would this do if I did a \/ \/ What do you think will happen? I actually don't know what'll happen. So let's see. It does the exact same thing. So what do you think this actually does? So why does it print 2 / like this? Yeah, the one that's going lower left to upper right. Right, yeah, exactly. So what will happen here is if it's not designed to do something specific like \t or \n, it'll fall back on just printing that character. So it's like you're escaping that one character to always, you're guaranteeing this one to be printed. It's okay here because apparently the C++ language says that the only way that a set of characters ends is with a double quote on the other end that's not escaped. Okay? So even though I have 2 backslashes here that correspond to a comment, this is still inside the thing that really is to be printed. But if we wanted to be very specific, I would do // // But apparently either way is okay. Yeah.
And start strings with a single quote?
No. So in some languages you can, like Python, but this one you have, for a string of characters, and by a string I mean of length at least 2, you have to start with a double and end with a double. We'll talk about things that are characters eventually, which are single characters. You can start with a single and end with a single. Yeah, so they are different. In Python, they're exactly the same thing. Other questions? All right, so yeah, of course put \n in double quotes because if you don't, then it'll try to think, well, does this correspond to some variable or something else? All right, so let's go back to that include thing. So where did we see this hashtag include thing? Where? Right at the very beginning, and what was that for? For IOStream. And what does IOStream as we know it do? Yeah. Right, yeah. So with cout and cin, we can say we want to print this thing or we want to get input that goes to this variable, that thing, things like that. Well, #include with the IOStream in general means that you're going to want to input the contents of another program into this one because you don't want to implement every single bit of functionality you ever need right in your program. You want to reuse components of another program. So it is what is called a preprocessor directive. So anything that starts with a # at the beginning has something to do with a preprocessor, whatever it is. So there are other things that are not include but start with a #. Those also have to do with the preprocessor. But # include means that we want to input the contents of another program. So that's what the directive means. So a directive is just another program you're going to want to put in your program. But the preprocessor does the moving it over for you. So it's not part of the C++ language. It's not seen by the compiler because the preprocessor operates before the compiler. It literally moves the contents of those other source files to your program, and then the compiler works on the resulting program. So it's not seen by the compiler at all. It runs right before the compiler starts. So, the example we've seen many times, we include IOStream, and there's no semicolon. So, okay, so let's do a short little project that might help you with your first assignment. So let's revert the changes back to what we had before, right at the beginning. So let's just run to make sure it actually works. And so it prints, we're going to calculate the area of a circle, and then it asks, what is the radius of the circle? So what do you think I should do right after this, this cout right here? It seems like it's asking for input. Well, what thing do we know has something to do with input? Cin, yeah. So do we have the directive that we need to work with cin? Well, where's cin defined in? In IOStream, right? Have we included IOStream? Great, perfect. So I want a cin, and should I do two less thans or two greater thans? Greater thans. And there's a reason for that, but so think cout. You can think of the less thans as this text is going into cout, And cin is coming out of the standard input by the user into something else. So it's pointing to the thing that it needs to go to. But what do I put on the other side of cin in the greater thans? I need to put a variable. Have I defined a variable yet? No. So, well, what type of thing are we trying to ask for here? The radius. So what types of things are radius or radii? So are they like Arkansas, or is that a radius, or is something like 5.0? Right, it's a number, right? It's not input text. So we need to define a variable that corresponds to a number. Well, we haven't really talked about it yet, but what thing have we seen that corresponds to numbers? This thing called double, right? So maybe we can use that here too. So double, and then now we got to give it a name. Well, I can give it any name I like, pretty much, but what seems like a reasonable name to have for radius? Call it radius, so that I know that this variable holds something that I know to be the radius. Okay, so then what do I do with the cin line then? Cn greater, then what? Then the variable I want to put the value into, which in this case is radius. All right, so radius here. And in fact, what's really cool about cline is that I'm starting to type, and it can predict what I'm going to say. If I push enter, it'll autocomplete for me, which is pretty cool. Okay, so that's good. So let's just make sure that the cin actually works. So maybe I try 5.0, like I said. And then, of course, since I don't do anything afterward, the program just finishes up there. Okay, well, now it says, well, I got to compute and display the area. Display the area, that's no issue. I can just work with cout on that. But how can I find the area of a circle from the radius? So can I put the double radius after this cout right there? I'm going to get there. Can I put the double radius there? Yes, because it didn't complain to me. What about here? No, why not? I use radius before I define it. What if I put it here? It's pretty obvious C-line is okay with that. But I'm declaring it before I'm using it. So my habit is to always define things right at the very beginning of the program or wherever I'm going to need it so that I have no issues whatsoever. But you can always define it right before you're going to actually use it. But how do I find the area of a circle from the radius? I know it's early, but hopefully we know how to compute areas of circles. Pi r squared. Okay, well, that's fine. Well, let's go through this one at a time. So let's try to work with the squared thing. What's one way I can find the square of this variable radius? Radius times radius. But what if I wanted to now work with another shape of some kind, maybe a sphere? Well, it has something to do with the radius cubed, right? So then I'm going to have to make a difference by typing out times radius again. Well, that may be fine if I have to do that in one place, but if I have this scattered throughout the program, then that might be an issue. So maybe that there's something in the C++ library that I can use to help me use their code, and I only have to change one thing possibly. So maybe let's look up online and see, is there something to do with computing the power of something else? So if I look for power C++, and then if we zoom in here, so there are a lot of references online. One of them that I use quite a bit is c++.com. So it seems pretty official. So let's click on that. It's legit. All right, so let's see. It tells us the what is called the signature of the function. Well, we haven't really talked about functions and what signature is, but it seems like, well, this POW function, whatever it is, takes something that's like a double, and then another one that's a double, and it says base and exponent. What do you think this double is out on the front? What's given back to me. So if I take some number and I take it to some exponent, also another number, I expect that to be also another number, which we have seen so far is a double, whatever that means. So let's see. So let's say I want to use that function, POW. It seems really useful. So maybe I will make a variable called area because that's what I want the variable to represent. So maybe I say, well, I want to call that POW function. And it says, well, I got to input the thing that's on the base and what thing is in the exponent. So what is it in this case? What is the base here? The radius. And what is the exponent here? 2. So maybe I'll do radius and 2. And then let's try to compile. Oh, it doesn't know what POW is. But wait, it said it's on C++.com, so therefore C++ knows about the function POW. Oh, what is this up here? CMath. It's between these two angle brackets. What is that called? A directive. What other directive have we seen? IOStream. So what did we do with IOStream to get the things we needed out of IOStream? Pound include. Well, maybe I can do the same thing with cmath in this case. So let's do include cmath. And it actually says, yeah, I know what cmath is. So I do that. Oh, then the error went away. So the key here is if you want to reuse some component of the C++ library, you need to include the necessary what is called a header file or directive. So here I included cmath, which has this function called POW. Okay, well, how do I display the area now? Cout. And then maybe to make the user's life easier, we say the area is, and then could I put radius like this? Sorry, area. The area is area. Well, how can I fix that? Yeah. Well, so if I put area like this, would that work? I need to put the less than or equal, less than sign, the two of them again. So what if I did this instead? There wouldn't be a space between where is ends and where the area calculation begins. So I put a space in between to make the user's life easier. So let's actually run this. So give me an example area of a circle. What was there? 7. All right. So I put 7. The area is 49. Great. Or is it not? Ah, I forgot the pi. Now I'm hungry. Oh, well, no, I did the squared here. I did POW radius of 2. Yeah. Yeah, so we forgot the pi. It's going to be a sad party. So, well, could I just put pi times this like this? No, so before I even compile this, and I won't actually, what do you think C-line is going to say?
It's not defined.
Right, I didn't define what pi is, and so it doesn't seem like C++ knows anything about pi. So let's see, let's look up pi C++. Maybe it has something included in the library that I can use. Maybe I need to include some other directive or header file or something like that. So the first references are in Stack Overflow. Who's used Stack Overflow? So I actually looked up a few of these before class, all of the answers on some of them are just plain wrong. Okay, so just be careful about what Stack Overflow says. But maybe let's look there and see. So if we look at the first answer, it says, well, some older platforms, probably not what we need. Include the necessary header file. Okay, well, maybe we need to do that. So let's include math.h, and maybe that'll work. And then, oh, it seems like this m_pi, all in caps, represents something about pi. So, and it seems like it's defined in this particular header file as #define. So what is anything that starts with a pound sign called? It's something to do with the preprocessor. So it has something to do with the preprocessor, but maybe I can just insert it right here. Oh, and it seems like it does work, so that's good. So maybe if we run, let's try the 7 again. And then it seems like, yeah, it works. Well, let's just verify for ourselves that works. So let's say 49 times pi. And indeed, for some degree of accuracy, it is, in fact, correct. So the reason why I don't like this is, what if we just didn't include that header? And I try to compile. It actually still works. So was that the math.h include necessary? No. So whenever you have a header that looks like .h, that's from the C programming days. So we're dealing with C++. That's actually what the C on the front of math represents. So here, if we look at cmath, so the way you look at where things are defined is if you do control-click on whatever it is, in this case cmath, and if I go to the declaration, then here is where the directive is, the source code of the directive. And if we look down, there's a lot of things commented out. In fact, a lot of things. But it has a whole bunch of things, using, a whole bunch of things. So what it's actually doing is it's using all of the necessary other directives that correspond to the math.h header. So here, it's a C++ version of the C header math.h. If you were working in C only, you would have to use math.h. You don't have access to cmath. So that's why I recommend you not to immediately use Stack Overflow. Use something like cplus.com, or there are a whole bunch of websites like that you can look up. How do I do this particular thing? What headers do I need to include? So hopefully this answer was pretty clear. So if I actually go to see where this thing is declared, if we look at the file name, it actually is math.h. So in fact, if instead of using cmath, I use math.h, it would work exactly the same. Because the only thing we need is something from math.h. If we needed something from cmath, then I would have to include that header. So it says it's defining this thing to be this really long value. Anyone know what this #define is before we get to what that means? Yeah. That's actually fully correct, but it defines what is called a constant. So here, mpi, because pi is a constant, it's defining this because we don't want the value of pi to actually change. So if I am trying to use mpi in my program, then I'm guaranteed that it'll never change. Why might this be useful? To use the system's pi value instead of I define my own pi value and use that in my program. Yeah. Right, it's an unnecessary definition, but why else might I want to do that? Yeah. Right, so what happens here is if you're using a 32-bit or 64-bit or even a 128-bit computer, this value will actually change. So if you run your same program, you may get less or more degree of accuracy. So it's not actually a constant here, but if you run it on the same system, you will always get the same value of pi. But another great benefit of this is if you use m_pi everywhere in your program, you're guaranteed to have the same value of pi everywhere. So instead of having a whole bunch of files and you have to define your pi value in every single one of them, if you decide, well, I need more accuracy now, you're going to have to change it in every one of those places. But if I use the systems one, then I'm guaranteed it'll always be exactly the same. Yeah?
When you use something like IO3 or cmath, like the preprocessor directives, does it have to be, like for example, here it might be there, but if you were coding it, say, in something else, do you have to have those files on your local drive that it knows what it's pulling from?
Yeah. So there's a particular order where C++ looks up the header files. It's actually quite complicated. But if you have them in the same directory as your program, it'll always work. But sometimes it looks up in particular files. So like lib include or some files. But it's not really important how it looks them up because we're not going to get to that level of detail. Other questions? Okay. So hopefully that was more than enough detail about that. So include, just as a reminder, is a preprocessor directive. It just copies things over from another program. And of course, we're not going to look at every single thing in the C++ language because no one knows everything about the C++ language. So if you want to figure out how do I actually do this, look it up online and then include the necessary header files as you need them. All right, so we've now seen variables several times. Let's actually dig in to see what a variable actually is. So we kind of talked about this last time where we said, well, a variable is a particular location in memory. So when you run the program, this, in the case of the program we just made, this variable called radius is stored somewhere in memory, okay? And anytime I want to access that variable, like if I'm cin a value to radius, it'll look up where that memory location is and store that in that memory location, that particular value. And if I want to use that value, like in the area calculation, it looks up in the same memory location and moves the value out into the CPU where it does the area calculation. So we always use this, assignment statements to store a value. So well, that's not actually true. So you can see why these slides are kind of not totally precise. So where did we actually use storing a value, but we didn't use an assignment statement for it? What about cin? Did I use a single equal sign, which is the assignment statement? No. So on the back end, if I look into the source files of cin, somewhere buried deep in there is an assignment operation that's happening. So, but we are not necessarily going to use assignment statements to store values all the time, like in the case of cout or cin. But the vast majority of the time we'll be storing a value with the assignment statement. Of course, it can change. We'll be talking about that constant thing I was referring to, the things when it can't vary. But variables by themselves can vary. And then, of course, you have to define it before you use it, as I've said numerous times. So if you want to store something into a variable, it always replaces the old value that was there. And you can't retrieve that value. So if I do something like this, then I define this variable called age, then I assign 17 to this variable age. If I print it out, it'll say 17 because that's the current value of what age holds. Then if I change it to 18, then we print 18 because that's the current value of age. And then, of course, it uses the assignment, the equals operator, which is called the assignment operator. then it has something on the right side and something on the left side. It's always a variable on the left side. So if I tried to do, So if I tried to assign age to the value 17, that wouldn't work because I'm not assigning to a variable. I'm assigning to what is called a literal, but we're not there yet. So we're assigning always to a variable, but the thing on the right side could either be a number or something like that, or it could be a variable itself. So it always copies the value over. But it seems like this thing right here, the previous value is overwritten and can no longer be retrieved. It seems kind of crummy. So let's think about this problem. So let's delete the program we have. So let's say that we have the user input 2 numbers and I want to swap them. So if the user enters X and then enters Y, then I want the values to swap between the two. So I want the X's value at the end to be whatever Y's value was at the start, and whatever Y's value is at the end to be whatever X was at the start. Okay, so we know how to do this, at the very beginning at least. So enter 2 numbers. Then I need to declare those 2 variables. Let's call them double XY. So remember, this comma just means I'm making 2 variables here called X and Y. So how do I input those 2 numbers? Cn for one of them, then I Cn for the other. One shortcut that you can do, you can already think, well, for cout, I can do this less than sign twice again if I want to print something else. I can actually do that with Cn as well. So if I wanted to do 2 things, I can do them like this. So it'll input X first, then it'll input Y. But then I want to print the swap values. Well, I got to figure out, well, how do I swap the locations, the values in X and Y? I can't just say, well, Y equals X. That moves the value of X into Y, right? But what just happened? Yeah. We're not there yet. So what does this statement do to the original value of Y? Yeah, it wrote over it. Whatever Y had before, X just replaced it. So what could we do? We can't obviously do X equals Y. Yeah. Let's make a new variable. And then let's call it, say, T for now. And then let's assign it to be one of the 2 variables. Let's just say X. And then what could I do with this? Yeah. X equals Y, and then what do I do? Y equals T. Oh, let's think about how this works. So the X's value gets copied over to T. So T has the value of X right now. What does the second statement, X equals Y, do? It overwrites whatever X has with Y. Okay, so X and Y have the same value now. So now I want Y to have X's original value. But where's that stored? In T. So then I move the value of T into Y. Okay? So let's see. Well, if I do this, then I'll just print X, and then here I'll put a comma, and then Y. So that is easier to see between the 2. So let's run this. So what are your 2 favorite numbers? 8 and 9. Did 7, 8, 9? All right. So I put 8, then nothing happened. Now what? It's waiting for the second value, right? So then I would put a 9, and then the swap values are 9 and 8. Right. So I entered 8, enter, then 9, enter. Yep. So Cn just waits until you press the enter key. So this is a way that we can swap 2 values, which will actually come very important as we get through the class. So if you know how to swap 2 values, you're in good shape. So just think about where the memory locations are and everything. But any questions about assignment? Assigning variables, yeah.
So yeah, like you said earlier, if we have any problem, we're almost certain to look it up and we can find answers.
Yep.
Okay. Any recommended places like YouTube or?
C++.com is a great one. The textbook is a great one if you happen to have it. YouTube's obviously a good one. There are plenty of tutorials there. Yeah.
I just want to, you said about Stack Overflow, stay away from that. Because everyone always tries to sound smart and show off. They don't actually answer.
Stack Overflow?
Yeah.
Be careful because I have a Stack Overflow account. No hard feelings. Any other questions? Yeah.
So, like, I could just be reading but
I still have 3 minutes. Yeah.
they assign a variable as int, but you assign it as double. Is there a difference between the two? Like, you declare it using double, but over there, it's int. Is there a difference?
INTH, where is that?
In the
Oh, yeah, so we'll talk about what INT means and what double means. It's just what is called the type. So what do you think int actually means? Integer. So yeah, that corresponds to integers. Double just means trying to represent real numbers. So I can enter like 5.2 or whatever. But we're not there yet.
So should we just use double from?
Yeah, just use double unless you only need int, then just use int. But we'll get to all that stuff in a bit. Yeah, so the weird thing about C++ is that pretty much every symbol can be used for different things. So you can see that the less than and greater than symbols are used for preprocessor directives. They're also used for these things, right? And so these things are called operators, and we'll get to what operators actually do. But the double less than symbol means the output stream operator. We'll get to what that actually means. And then the double greater than means the input stream operator. So that as we get down the line, you can redefine what these actually mean. But another use for these is if you want to compare two values, you can just use less than or greater than. So it's actually quite difficult if you want to write a compiler for this because each symbol can be used for many different purposes. Yeah. I didn't hear the first part. Watch the videos, go to office hours, ask over email, ask questions, go to the lab sessions. Those are important. Yeah. Yeah.
So if you're looking for more visual learner, I suggest that you find someone that knows how to do it and show them step by step how to do it.
Slides are a great help too.
Yeah.
Other questions? All right, so let's do one more slide at least. So we saw this. So all assignments do, well, not your programming assignments, just variable assignments do is move something on the right to something on the left. But if we want to talk about initialization, here, this is kind of what I said before. You can do some calculation or whatever on the right and store to a variable, but you can't store something to what is called a literal, but we haven't talked about literals yet. So it doesn't make sense. I'm storing size into 5. That doesn't actually make sense. So that's assigning. Initializing is when you declare the variable. So remember when in our earlier program, when we had double, I guess, num1 equals 12, that's the initialization of the variable. So when you define a variable, which is putting that int or double thing on the front, then you could give it an initial value or you don't have to. So in this case, right up here, int size, I'm not giving it an initial value. So we don't know necessarily what value size has right now until we give it a value. In this case, it actually is 7. But here at the bottom, we have int length equals 12. Length has a value of 12 right at the very start. Any other questions? Yeah, quickly.
Is the difference between double and int basically int needs to have a value to insert it, but double
We'll talk all about that, but it's much more complicated than an answer I can give in 10 seconds. I promise we'll get to that. Other questions? Yeah. It'll always be a double. Even if you use an int on the right side, it'll be a double, whatever that is. Great, I'll see you Monday.